This is Mrs. Appia with Lesson 13, Angle Sum of a Triangle. Student outcomes for this lesson. Students know the angle sum theorem for triangles. The sum of the interior angles of a triangle is always 180 degrees. Students present informal arguments to draw conclusions about the angle sum of a triangle. Pause the video and copy the essential question for Lesson 13. What two pieces of knowledge help prove the sum of interior angles of a triangle? The angle sum theorem for a triangle states the sum of the interior angles of a triangle is always 180 degrees. Notice on our three different triangles here. We have our first triangle with angles 1, 2, and 3. And the sum of angles 1, 2, and 3 is equal to the angles 4 plus 5 plus 6, which is also equal to 7 plus 8 plus 9, which is equal to 180 degrees. What this means, these three angles of this acute triangle add up to 180 degrees. These three angles of this obtuse triangle also add up to 180 degrees. And these three angles of this right triangle also add up to 180 degrees. So this theorem states it doesn't matter what type of triangle it is. The three angles always add up to 180 degrees. Additionally, note that the sum of angles 7 and 9 over here must equal 90 degrees because of the known right angle of this triangle being 90 degrees. So 90 plus 90 more from these two equals 180 degrees. In the exploratory challenge, these directions are just describing this figure. So there are no additional instructions for us, they're just describing it. So in this triangle A, B, C, there is a ray from B to C, including point D, and point C is between B and D. Through C, draw a line parallel to AB. So here is through C, parallel to AB. So we know that AB is parallel to CE. Extend your parallel lines AB and CE. Line AC is the transversal. So this one is the transversal that cuts through the parallel lines. Name the three interior angles of triangle A. I believe this is supposed to say triangle ABC. Recall that when you name an angle, you name it with three letters and the vertex is the middle letter. So our first angle, let's call this angle 1. This will be angle CAB. Angle 1 is angle CAB. Remember that the vertex is always the middle letter. Next, let's take a look at angle 2. We'll call this angle 2. And that angle, the vertex is B, so that will be the middle letter. And then you can either say ABC or CBA. I'm going to call it ABC. Remember, what's important is that the vertex is the middle letter. Next, this will be angle 3. Angle 3 has a vertex of C, so that will be the middle letter. So you could call that angle ACB or BCA. I'm going to call it BCA. Next, name the straight angle. So here on this straight line here, this is the straight angle. And our middle vertex will be our middle letter. So we can call this BCD or DCB. I'm going to call it angle BCD. And I'm also going to give it a name, line M. Next, what kind of angles are ABC and ECD? So angle ABC, that was angle 2. And ECD. Now ECD we have not named yet, so let's go ahead and name that. ECD is this angle. Let's call that angle 5. Angle 5. So we want to know what kind of angles, or what is the angle relationship between angle 2 and angle 5. Well, we know that these are corresponding angles on parallel lines. They are corresponding angles on parallel lines. What does that mean about their measure? We know that since they are on parallel lines, that they are equal in measure. Next, what kind of angles are BAC and ECA? So BAC, let's go over here. BAC, that was angle 1. And ECA, we have not named that angle yet, so let's go ahead and name that angle 4. Angle 4. So we want to know what kind of angles are angle 1 and angle 4. These are alternate interior angles. They are inside the parallel lines on alternating sides of the transversal. They are alternate interior on parallel lines. And what does it mean about their measures? We know that since they are on parallel lines, that they are equal in measure. Question E. We know that the measure of angle BCD, now remember that BCD is our straight angle. Here's our straight angle, BCD, is equal to BCA, which is this angle, plus ECA, which is this angle, and ECD, which is this angle, is 180 degrees. So we had angles 3, 4, and 5. Okay, so we know that the 3 angles on the straight line have a sum of the 3 angles adding together, which is 180 degrees. Use substitution to show that the 3 interior angles of the triangle have a sum of 180 degrees. Okay, so the triangle, this was angle 1 and this was angle 2. And what we want to prove is that angle 1, 2, and 3 have a sum of 180 degrees. So here we had angle 3 plus angle 4 plus angle 5 equals 180 degrees. And those were the 3 angles on angle BCD. And it says use substitution to show that they have a sum of 180 degrees. So here's what we know. We know that angle 1 and angle 4 have the same measure. So I'm going to replace angle 4 with angle 1. We also know that angle 2 and angle 5 have the same measure. So I'm going to replace angle 5 with angle 2. Then I have the 3 angles in my triangle. Angle 3, angle 2, and angle 1. And they equal 180 degrees. So we have used substitution to prove 180 degrees in a triangle. What we did is we looked at the relationship on parallel lines. We know that angle 1 and angle 4 are equal in measure. We know that angle 2 and angle 5 are equal in measure. Then we looked at angles 3, 4, and 5, adding up to 180 degrees. And then we said that angle 1 is equal to angle 4, and angle 2 is equal to angle 5. And since we know that 3, 4, and 5 add up to 180, we also know that 1, 2, and 3 add up to 180 using substitution. In this next exploratory challenge, The directions at the top are simply explaining what the diagram looks like. So it says the figure below showing parallel lines 1 and 2. So here is, let's take this, and this will be line 1, and it is parallel to line 2. Then it says let M and N be transversals. So this is a transversal intersecting parallel lines, and let's make another one of those. And this one is also a transversal intersecting parallel lines. All right, now name the triangle in the figure. So our triangle is BCF. Let's write that down. The triangle in the figure is triangle BCF. Next, name a straight angle that will be useful in proving that the sum of the interior angles of the triangle is 180 degrees. So we have a lot of straight angles here, and you think which one would work to help prove this? So let's just go back for a minute and look at the previous diagram. And there are lots of straight lines here as well, or straight angles. The one that we used had 3 angles on the line, not just 2 angles like this one, or 2 angles like this one. It had 3 angles, and one of the angles is in the triangle, is an interior angle of the triangle. So we're looking for 3 angles together on one vertex, and one of them is part of the triangle. So here we have 2 angles on a straight line. Here we have 2 angles on a straight line, and here we have 3 angles on a straight line, and one of them is part of the triangle. So this is the straight line that we will use. And let's just make that a different color. So that's the line that we're going to use. When you're looking for a straight angle that's useful, it should have 3 angles on the same straight line sharing a vertex, and one of the angles is one of the 3 angles in the triangle. And that would be this angle right here. Next, write your proof below. All right, so the proof that we know that 3 angles have a sum of 180 degrees when they're on a straight line. And we want to use one of them that is part of the triangle. So we want to use these 3 angles. We know that those 3 angles will add up to 180 degrees. We want to show that these 3 angles also add up to 180 degrees. So we'll take a look at the angle relationships on the parallel lines. Let's number our angles. We'll call this angle 1, 2, 3, 4, and 5. We know that angles 4, 3, and 5 are on a straight line and that they will add up to 180 degrees. So I'm going to write that over here. Angle GFE is equal to angle 4 plus angle 3 plus angle 5. And that is just the definition of a straight line having 180 degrees. Then I want to look for angle relationships. I know that angle 3 is going to remain in my equation because it is one of the 3 angles of the triangle. But I also need to include angle 2 and angle 1. So looking for angle relationships. Angle 1 and angle 4. These are called alternate interior, and they are equal in measure. Angle 4 and angle 1 are equal in measure. Why? Angle 4 and angle 1 are alternate interior on parallel lines, so we know that they are equal. Then I also know that angle 2 and angle 5 are alternate interior on parallel lines. Angle 5 and angle 2 are alternate interior on parallel lines, so they are equal to each other. Angle 2. So since I know that angle 5 is equal to angle 2, I can replace that in the equation. And angle 4 is equivalent to angle 1, so I'll replace that in the equation. And angle 3 is the third angle in my triangle. So if I add those three angles together, that will have a measure of 180 degrees, the same as the measure of angle GFE from the previous equation. This angle equals 180 degrees. These three angles add up to 180 degrees. These three angles also add up to 180 degrees. This is using substitution to prove this theorem. In this lesson, you have learned all triangles have a sum of interior angles equaling 180 degrees. Proof of this is dependent on knowledge of straight angle and angle relationships formed by parallel lines cut by a transversal.